Imagine waking up and the world feels off. The air is different, the sky seems unfamiliar, and there's an unsettling chill in the breeze. The air bites in spring, snow buries London and Paris for months, and winters stretch on brutally. It's as if the seasons have forgotten their place, leaving cities in a perpetual state of winter. Meanwhile, Miami and New York swelter under relentless heat and rising seas. The sun beats down mercilessly, and the water levels creep ever higher, threatening to swallow the coastlines. This isn't science fiction, it's a future some scientists warn could happen if the Gulf Stream shuts down. A scenario where the balance of nature is tipped, leading to extreme and unpredictable weather patterns. The Gulf Stream is more than just an ocean current, it's a climate engine. It regulates temperatures, influences weather systems, and supports marine life across vast distances. If it stops, weather patterns go haywire. Farming seasons vanish, food becomes scarce, the land that once flourished now struggles to yield crops, and the farmers face an uncertain future. Storms grow unpredictable, and ocean life is thrown into chaos. Marine creatures, unable to adapt quickly, find themselves in peril, and the once vibrant ocean ecosystems begin to falter. It's a domino effect, starting in the ocean but touching us all. The changes ripple through the environment, affecting every aspect of life on Earth. The Gulf Stream has shaped civilizations and ecosystems for thousands of years. It has been a silent partner in our history, guiding explorers and nurturing coastal communities. Now, our actions are pushing this ancient current toward a breaking point. Industrial activities and pollution are altering the delicate balance, threatening to disrupt this vital oceanic conveyor belt. We're part of Earth's complex system, not just passengers. Our choices and actions have a profound impact on the planet's health and future. Science gives us the tools to understand and act, not just to worry. Through research and innovation, we can find solutions to mitigate these threats. By studying the Gulf Stream, scientists are working to give us an early warning. Their efforts aim to predict changes and help us prepare for potential impacts. This isn't just doom and gloom, it's a call to action. Communities around the world are coming together to make a difference, planting trees, reducing emissions, and advocating for change. The first step is understanding the threat. Knowledge empowers us to take informed actions and make decisions that can alter the course of our future. The next is working together to keep this scenario in the realm of fiction. Collaboration across nations and cultures is essential to address these global challenges. Let's dive in and explore this amazing ocean current. By understanding its complexities, we can appreciate its importance and work towards preserving it for generations to come. To truly understand the Gulf Stream and its importance, let's zoom out and look at the bigger picture, our entire planet and its interconnected oceans. Earth's oceans are in constant dynamic motion, forming a vast global conveyor belt known as thermohaline circulation. This isn't just a single current, but a complex network of moving water that connects all the world's oceans together. This system is powered by differences in both temperature and salt content. Thermo for heat, haline for salt. These differences drive the movement of water, allowing the ocean to transport heat around the globe and help balance climates everywhere. Warm water from the tropics, heated by the sun, travels northward along powerful currents. As it moves, it releases heat into the atmosphere, warming the air and the countries it passes by. That's why Europe, even at high latitudes, enjoys much milder winters than places like Canada, which are at the same latitude but lack the warming influence of these ocean currents. As this water continues north, it cools down and becomes saltier, especially as sea ice forms and leaves salt behind. This makes the water denser, causing it to sink deep into the ocean in the North Atlantic. This cold, salty, and now very dense water then begins a long journey back toward the equator, traveling deep below the ocean's surface, hidden from view. Eventually, after traveling thousands of miles, these deep currents rise again in the Pacific and Indian Oceans, bringing cold, nutrient-rich water back to the surface and restarting the cycle. This global circulation isn't just about moving heat. It also carries oxygen and nutrients to the deep sea, supporting life in some of the most remote parts of the ocean. Thanks to this conveyor belt, marine life thrives, coral reefs flourish, and our planet's climate remains relatively stable over time. But this is a delicate and finely balanced system. Even small disruptions can have dramatic consequences, affecting weather, sea life, and even human societies. For thousands of years, the conveyor belt has helped regulate Earth's climate, but history shows it's not invincible. Past disruptions have triggered major climate shifts. If this system falters, the effects can ripple across the globe, causing extreme weather, shifting rainfall patterns, and threatening food supplies. That's why understanding this system is so important. It's the key to predicting and preparing for our climate's future. The Gulf Stream is one of the most crucial links in this global chain, acting as a major artery in the planet's circulatory system. If the Gulf Stream weakens, the entire conveyor belt could slow down or even stop, putting the whole system, and our climate, at risk. So, let's take a closer look at how the Gulf Stream fits into this powerful global engine, and why its health matters to us all. The Gulf Stream is a powerful, warm ocean current that begins its journey in the Gulf of Mexico, where tropical waters gather and are set in motion by the rotation of the Earth and prevailing winds. From there, it races up the U.S. East Coast, hugging the shoreline and carrying vast amounts of heat northward, shaping the climate of the entire region. The current then makes a dramatic turn, crossing the vast Atlantic Ocean towards Europe, acting as a massive conveyor belt for warm water. The Gulf Stream moves more water than all the world's rivers combined, a true force of nature, constantly in motion and influencing weather patterns on a global scale. This powerful current shapes weather on both sides of the Atlantic, fueling hurricanes in the tropics and delivering warmth to Europe, making it much milder than other regions at similar latitudes. For example, London's winters are famously mild compared to Calgary's, even though both cities are at similar distances from the equator. The Gulf Stream's warmth is the reason why snow is rare in London, while Calgary faces harsh, snowy winters. But the Gulf Stream is just the surface part of a much larger and more complex system, the Atlantic Meridional Overturning Circulation, or AMOC, which acts as the Atlantic's engine for moving heat and water around the planet. AMOC is the Atlantic's branch of the global ocean conveyor belt. Warm surface water flows north where it cools, becomes denser, and sinks deep into the ocean, then travels southward as a cold, deep current, completing a vast loop that helps regulate Earth's climate. If the sinking of cold water in the North Atlantic stops, the entire system could grind to a halt, disrupting the flow of heat and energy across the globe. The Gulf Stream would weaken dramatically or even stop short of reaching Europe, leading to much colder temperatures and more extreme weather in many regions. The engine of the AMOC is located in the North Atlantic, near Greenland and Iceland. If this engine fails, the entire conveyor belt system could collapse, with far-reaching consequences for global climate. That's why scientists are constantly monitoring these waters, deploying buoys and research vessels to track changes in temperature, salinity, and current strength, searching for early warning signs of trouble. The fate of our climate may depend on the stability of these ocean currents. Understanding the Gulf Stream and AMOC is crucial for predicting the future of weather, sea levels, and life on Earth as we know it. What could disrupt this massive ocean engine? Melting ice. As the planet warms, Greenland's ice sheets and Arctic sea ice melt, pouring billions of tons of fresh water into the North Atlantic. This fresh water dilutes the salty ocean, making it less dense and less likely to sink. If the water doesn't sink, the conveyor belt breaks. The Gulf Stream slows and the AMOC weakens or stops. We're tipping the balance by flooding the system with fresh water at an unprecedented rate. Earth's history shows this has happened before. Sudden fresh water surges shut down the AMOC and triggered rapid climate shifts. Now, human-caused warming is creating similar conditions but much faster. We're running a risky experiment with our climate system. The melting Arctic is the wild card. If the AMOC collapses, Europe and North America face very different futures. Europe loses its central heating. Winters could drop by 5–10 degrees Celsius, making cities like Paris and Berlin feel like Siberia. Farming would suffer, food shortages could follow, and ecosystems would be thrown into chaos. Meanwhile, the U.S. East Coast would see sea levels rise by up to a meter, flooding cities like Miami and Boston. Warm water pooling in the tropics would supercharge hurricanes, making them more destructive. Weather patterns would become extreme and unpredictable. The stable climate we rely on would vanish. Both continents would face climate chaos, but in opposite ways. The Gulf Stream connects their fates. A collapse would force both to adapt to a new, harsher reality. The stakes couldn't be higher. An AMOC collapse wouldn't just hit Europe and North America. The whole planet would feel the shockwaves. Tropical rain belts could shift south, causing droughts in the Amazon, Africa, and Asia. The Amazon could dry out, releasing more carbon and speeding up global warming. The oceans would suffer too. Less oxygen and nutrients would create dead zones, devastating fisheries and marine life. Fish populations would crash, threatening food security for millions. The slowdown in ocean heat uptake could actually speed up warming elsewhere, especially in the southern hemisphere. The AMAC helps pull heat into the deep ocean. If it stops, more heat stays at the surface. This isn't just a regional problem, it's a global climate shakeup. The consequences would be unpredictable and dangerous for everyone. The world's climate web is more fragile than we think. How likely is an AMOC collapse, and when could it happen? Most climate models say a full shutdown this century is unlikely, but a 2023 study warned it could happen as soon as 2025, with a central estimate around 2060. This sparked debate. Many scientists urge caution, noting the study used indirect data. Still, all agree on two things. The AMOC is weakening, and Greenland's melting ice is pushing it closer to a tipping point. Direct measurements show the AMOC is at its weakest in over 1,000 years. Whether collapse is decades or a century away, the risk is real. The consequences are so severe, we can't afford to ignore the warning signs. Scientific uncertainty doesn't mean safety, it means urgency. The time to act is now, before the tipping point is reached. Our window to prevent disaster is closing. Science is our first line of defense against an AMOC collapse. Around the world, scientists monitor the AMOC with high-tech tools: sensors, satellites, robotic floats, and underwater gliders. The rapid array, stretching from Florida to Africa, gives real-time data on the current's strength. Since 2004, it's revealed a long-term weakening trend. Satellites and Argo floats add even more detail, helping scientists refine their models and predictions. The goal: find early warning signals before it's too late. Like doctors watching for symptoms, scientists search for signs the AMOC is nearing its tipping point. Combining direct measurements with advanced models, they're racing to reduce uncertainty. This global effort is essential for giving us a fighting chance. The clock is ticking, but knowledge is power. The threat is huge, but you are not powerless. Climate change, driven by fossil fuels, is the main cause, and that means we can change the outcome. Every action to cut carbon emissions helps slow warming and protect the AMOC. Talk about what you've learned, spread awareness and demand action. Make small changes, save energy, walk or bike, reduce waste. Support leaders and businesses that fight climate change. Your choices matter now and in the future. This is a mission for all of us together. Humanity can do incredible things when united by a common goal. The Gulf Stream story is a warning and an invitation to protect our planet. Let's get to work.